Hi, in this video, I will be showing you problem number 10 of chapter 11 section 6. Use the ratio test to determine whether the series is convergent or divergent. Sigma n varying from 0 through infinity, negative 4 to the exponent n divided by 2n plus 1 factorial. The problem states we have to apply the ratio test. So what is the ratio test? So if limit is n approaching infinity, the ratio of absolute value of the ratio of the n plus first term over the nth term, a sub n plus 1 over an, is L, and if L is less than 1, then the series sigma an is absolutely convergent. But absolute convergence means convergent, therefore it is convergent as well. If limit as n approaching infinity, absolute an plus 1 over an, the ratio of the n plus first term over the nth term, absolute value of that is equal to L, and if L is more than 1, then the series an is divergent. If limit is n approaching infinity, absolute a sub n plus 1 over a sub n equal to 1, then the ratio test is inconclusive, which means no conclusion can be drawn about the convergence or divergence of sigma an. So let's find what the limit is n approaching infinity, absolute an plus 1 over an, which is limit is n approaching infinity. So what we see here is a nth term, and then we are going to change the n to n plus 1 here in order to get a sub n plus 1. So it is negative 4n plus 1 over 2 times n gets replaced by n plus 1 over here. So 2 times n plus 1 factorial divided by a sub n, which is the given expression here, which is negative 4 to the power n over 2n plus 1 factorial. So you are dividing a fraction by another fraction, so you are going to flip and multiply the denominator fraction. So it is limit n approaching infinity of negative 4 to the n plus 1 over 2n, if you distribute 2n plus 2 plus 1, so that will be 2n plus 3 factorial, times you are going to flip and multiply, that is 2n plus 1 factorial divided by negative 4 to the exponent n. So keep in mind everything is taken with the absolute sign. So now we can do some simplification here. So negative 4 to the power n, negative 4 to the n plus 1. So that leaves us with the negative 4. Then also you remember, so if you have a 5 factorial, which is continued product up to 5, so which can be written as 3 factorial times 4 times 5, or whatever the necessity may be here in the simplification, we can also write 4 factorial times 5. So in this case, the idea is to cross the numerator expression with the denominator expression as much as possible. So we are left with the negative 4 on top. Here we have 2n plus 1 factorial, and 2n plus 3 factorial is 2n plus 1 factorial times 2n plus 2 times 2n plus 3. So we have written something like this. 5 factorial is 3 factorial times 4 times 5. So it is 2n plus 3 factorial is 2n plus 1 factorial times 2n plus 2 times 2n plus 3. So that way you can cross out 2n plus 1 factorial with the 2n plus 1 factorial on top. So we get limit as n approaching infinity, absolute negative 4 over 2n plus 2 times 2n plus 3. So which is limit n approaching infinity of 4 divided by the denominator, which is 2n plus 2 times 2n plus 3. The denominator is very large as n approaching infinity. So it is 4 over infinity kind, which is equal to 0. Here we notice it is L, where L is smaller than 1. So if we notice, if L is more than 1, then the series is absolutely convergent and therefore convergent. So that's exactly what we have here. So L is less than 1. Therefore the series sigma n varying from 0 through infinity, which is negative 4 to the exponent n over 2n plus 1 factorial is absolutely convergent by ratio test, and absolute convergence would imply convergence, and therefore the series sigma negative 4 to the power n over 2n plus 1 factorial is convergent. So whenever you do these kinds of problems for convergence or divergence, you state the test that we are applying. Here we are asked to do by ratio test. State the test and what the hypotheses are, and then prove one of the three conditions that is relevant for the problem, and then arrive at the proper conclusion in the problem. So we are showing that the limit is less than 1, and therefore it becomes absolutely convergent. And absolute convergence means convergent. Hope this video